let us take this one. So this is of course 2-chloro butane, right? And the common name is, this arrangement, I mean, having a methyl group on one end, ethyl, or let me say other than methyl group on the other end, is called secondary arrangement. So we call this secondary butyl chloride. And of course, this is a 2-degree alkyl halide. Next. Of course, can be numbered in different ways. See, this is of course called 2-chloro, 2-methyl propane. And this arrangement is called a tertiary arrangement. Tertiary butyl chloride. Now this is a 3-degree or a tertiary alkyl halide. This one. See, it's 1-chloropentane. Arrangement is normal. A straight chain of carbon atoms is what you have. So this is N-pentyl chloride. You can also say N-amyl chloride. Okay. And this, of course, is a primary alkyl halide. Yes. 1, 2, 3, and 4. So this is 3. Okay. 1-chloro, 3-methyl butane. Right. And see, the arrangement is iso again. So this is iso. Now you can call it isopentyl chloride. Or of course isoamyl. Pentyl is always called amyl. Now this again is a primary alkyl halide. 1, 2, then 3. So this can be written as 1 chloro, 2 dimethyl propane. And you know this arrangement is called neo arrangement, where see there is a 4-degree or quaternary carbon, but still this is a primary alkyl halide. Now this of course is neopentyl chloride. Okay, that's it. Let us go for the dihalogen derivative. See, the general formula of dihalogen derivatives is CnH2nX2, and the IUPAC name is dihaloalkane. Okay, let me take some examples. See this. See, the IUPAC name of this is 1,1-dichloroethane, right? And the common name is of course specific. Ethylidene chloride. Look at this. Dene, ethylidene chloride. And you know, this of course is famously known as, now look at the arrangement, wherein you got two halogen atoms attached to the same carbon. So this kind of an arrangement is called geminal or gem. Two halogen atoms are on the same carbon, right? Now we can say that this is gem dichloroethane, geminal. You know, the word geminal in Latin refers to twin. Okay, Gemini, geminal. Now, this is 1,2-dichloroethane. Okay, and the common name is ethylene dichloride. Ethylene dichloride. The previous one was ethylidene. Now this is ethylene dichloride. And see this kind of an arrangement in which you got two halogen atoms. On adjacent carbon atoms. We call this vicinal arrangement and is represented by Vic or Vis. Okay. See in Latin, vicinus means neighbor, nothing but adjacent. Okay. See this can be written as vicinal dichloroethane. Geminal and vicinal are used only while writing the common names. Okay. Now the trihalogen derivative. See the general formula of trihalogen derivatives can be given as CnH2n minus 1 X3 or CH X3. The IUPAC name is, of course, trihaloalkane. Now, look at this. So this is, in fact, a trichloro derivative of methane. So we can call this trichloromethane. The common name is chloroform. This is tribromomethane. Bromoform. Triiodomethane. Iodoform. Okay. Finally, the tetrahalogen derivative. The general formula is CX4. IUPAC name is tetrahaloalkane. Look at this. So this is tetrachloromethane. carbon tetrachloride. Next. Tetrabromomethane. Carbon tetrabromide. Tetraiodomethane. Carbon tetraiodide. Okay. So these are mono, di, tri, tetra halogen derivatives. Let us take some other examples. Look at this. Yes. Now, if suppose this is taken, see in this case the IUPAC name can be given as, of course, 1, 2. But even if this chlorine is connected to this carbon also, it will be 1, 2 only. I mean 1 chloro only. So we need not write that. I mean, we need not give numbering. Can simply be written as chloro-derivative of ethene or chloroethene. And of course, this arrangement is vinyl. So is vinyl chloride. Now look at this. If this is the case, yes, 1, no, 1, 2, 3. So this can be written as 3 chloro. Even here also, of course, even if the double bond is here, it will be propene only, prop 1 ene only. So either you write it as prop 1 ene or simply propene, doesn't make any difference. And of course, the famous name or the common name. This arrangement is allyl, right? So let us say that this is allyl chloride. Okay, let us take this. See, these are the things we get too often when we discuss the halogen compounds topic. So it is very important to know the names of these compounds. So this can of course be called, it is actually chlorophenyl derivative of methane. Okay. So the IUPAC name is chlorophenylmethane. Common or famous name is benzyl chloride. Benzyl. Okay. Next, let us consider this. See, this is dichlorophenylmethane, right? This is called benzyl chloride. You can also say benzyl dichloride, but benzyl itself refers to the thing that it has two chlorine atoms. So benzyl, of course, di. Okay, benzyl, benzal. Okay, take this one. See, this is trichlorphenylmethane. Common name is benzo trichloride. So benzyl, benzal, and this is benzo. Okay. Next. See, this one can be given as 1-chloro 2-methyl benzene. Or else, benzene with the methyl group is called a toluene. This is even accepted by IUPAC. So we can also call this. Now you have to start from the carbon attached to methyl group. I mean, numbering should be given from the carbon to which methyl group is attached. So that will now become 2-chlorotoluene. That is an interesting point. Or you can say ardochlorotoluene. Methyl benzene is toluene. Okay. Preparations of alkyl halides. The first one is from alkane. It can be given as excess of alkane reacts with halogen in the presence of sunlight or UV light or at a high temperature. A free radical substitution reaction. Hydrogen free radical is replaced by halogen free radical. Now we have already seen this in our alkanes topic. Even the mechanism is taken properly. So just go through that once again. The mechanism of halogenation, types of monohalogenation products, their percentages and all. Okay. Now this. See, alkanes react with sulfuryl chloride. In the presence of sunlight or traces of peroxide. To form alkyl chloride, HCl and sulfur dioxide. Let us take the mechanism of this. Taking a peroxide, acetyl peroxide. See, this arrangement is called acetyl, ethanoyl. In the presence of sunlight or UV light, this undergoes homolytic fission. Okay. To form this. Two such species, two such free radicals. And now again, this, which will result in these free radicals. Now we can form a bond between these two. So from this we get two methyl free radicals. Of course, carbon dioxide. Now this methyl free radical combines with SO2Cl2, sulfuryl chloride. take a chlorine free radical from this, you will get methyl chloride. Then, of course, the other free radical, SO2Cl free radical. Now, this SO2Cl free radical forms a chlorine free radical this way. Now, this chlorine free radical combines with alkane. Here, you can actually take the homolytic fission again, results in two free radicals, combine these two. Okay, so we get alkyl free radical and HCl. Now this alkyl free radical with the sulfuryl chloride forms RCl, then the SO2Cl2 free radical. So this again goes into this step. So the process just goes on. Okay, so this is the mechanism. Of the preparation of alkyl halides from alkene.